This is number 45 in chapter 10. It's looking at geometry, but now the molecules are a little bit more complex. We want to determine the geometry about each interior atom in each molecule and sketch the molecule. And we're kind of given a structure, at least a rough structure for the molecule. And so here we have a CH3OH. CH3OH now has more than one element in the middle, and remember we try to represent this with these carbon based molecules by showing you connectivity, or one group next to another group. Remember, hydrogens cannot be found in the middle of the molecule, and so these guys would all be on the periphery. And so if we look at methanol, we should end up with a structure, at least a rough two-dimensional structure that looks like this, with the carbon and the oxygen bound together, each with their octet, and the hydrogens all around the peripheral. And so now we want to draw this in a three-dimensional space. I tend to write the kind of the base skeleton that we see along the left to right here with the two-dimensional drawing as kind of like an up and down shown here. And then I begin to write in all the rest of the groups with the geometry. The carbon has 4 groups, and so we have a tetrahedral. Molecular geometry, that's also the same for the electronic geometry. And the other element that would be in the middle would be the oxygen. The oxygen in this case is tetrahedral with electronic geometry, but would be known as bent if we're looking for molecular geometry, which is what they're asking in this question. So both the carbon and the oxygen have that electronic tetrahedral orientation, but if we're looking at molecular nomenclature, the carbon is tetrahedral and the oxygen is bent. We go to part B. Part B has CH3O, CH3, and if we keep with that rough skeleton, we would end up with a structure that looks like this in 2 dimensions, with having those 2 CH3 groups on either side of the oxygen. And now if we're to write this in a 3-dimensional representation, again I would write that left to right elements that are along that backbone, along the center of the molecule here, as ups and downs, and then putting in the appropriate geometry. Each of those CH3 groups, those carbons, are both tetrahedral, so we would expect a tetrahedral on the left and the right of the molecule. And then we have our oxygen with its 2 lone pairs. And so our carbon and our oxygen are tetrahedral electronically, but if we look at their molecular naming, we have the same thing as part A, in that the carbon is tetrahedral and the oxygen is actually bent. Part C is looking at hydrogen peroxide, H2O2, and there's only really one way to put this molecule together with those hydrogens on the terminus, with then our oxygens both being in the middle. And so again we end up with a tetrahedral electronic geometry for the oxygens, but because of the lone pairs, their molecular name would be bent. So both of those oxygens would actually be bent. That is number 45.